Hello everyone. Today we are going to discuss the optimal page replacement algorithm. Okay, so what is page replacement algorithm? There are basically four very popular page replacement algorithm. First one, first in first out. This one already we have discussed. Optimal page replacement algorithm is basically what is the concept? Our main memory, okay, it is having less number of slots, okay, less number of frames, and our processes, okay, we will be having very large number of processes, and also the length of the process will be more, okay. So there will be lot of pages in the processes, and there will be lot of processes. So the CPU, whenever it execute some process, it will request all those page numbers, okay, all those page number which is currently required by the CPU. It will request this page number. At that time what we'll do, I will bring the pages from the secondary memory to the main memory, to the all the frames of the main memory. If my main memory is already occupied by other pages, then I will follow this page replacement algorithms, okay. I will follow any of the strategy that is given in the page replacement algorithm to replace. If suppose I bring some page number p1 here to the main memory, already available, out of already available pages, which one I am going to replace, okay. That those strategies or those algorithms are known as page replacement algorithms. So in case of optimal page replacement, we will replace page which is not used in the longest duration of time in future. So we'll see, out of all the pages that is there in the secondary memory, or out of all the requests that is given by the CPU, which one is not used in the longest feature, okay. Which one is not used in the longest feature? If it is already occupied in the main memory, and suppose that particular page, it will be requested by the CPU in the longest feature, okay. So then for the current request, I'll replace that particular page in the main memory, okay. So with example it will be more clear. Let's discuss this example. So as you can see that here the reference string will be given, okay, and the number of frames in the main memory will be given. So in the main memory, for the same string we will see with number of frames 4 what will be the page fault, and with number of frames 3 what will be the page fault, okay. So to solve this kind of problem, as we have discussed in before, that we will first mark the frame numbers. If frame number is 4, so frame number this is 1, frame number this is 2, this is 3, this is 4, okay. And here what is page fault? Page fault is CPU has requested a particular page. If it is already there in the main memory, then CPU can easily refer that, right. But if it is not there in the main memory, then page fault occurs, okay, and I have to bring that page from the secondary memory to main memory. So that is called then it says that we have page fault, okay. So initially here you see what is the first request, 7, right. Whether 7 is there in the main memory? No. So I will mark it as a page fault, okay. So by a star I am indicating that page fault. You can use any kind of other convenience way to mark that, okay. So I'll write here 7. Then these 4 frames only I will duplicate here, okay. So what is the next request? Next request is 0. Whether 0 is there in the main memory? Already 7 is there in the main memory, 0 is not there. So again page fault will occur. so 0 I'll write here. Okay, likewise I need to duplicate this particular frames up to the number of requests that is sent. Okay, this is just for my convenience, so that I can count how many page faults are there. Okay, and how the pages are getting replaced. To visualize that, I have to represent it in some form. Okay, this is one of those forms. Okay, and most popular form. So whenever this kind of problem is there, we first have to allocate these frames. Okay, so let me just write those. So and on the top I'll write this same request I'll write here. Now it is 1, then 701, after that 2 0 3 0 4 2 3 0 3 2 1 2 0, then 1 7 0 1. Correct? Now we can quickly find out. So again, what is the next request? 1. Is it there in the main memory? No. So I'll mark it as a page fault 1. I'll write here. Then 701, I'll just write copy it like that. Then the next request is 2. Whether it is there in the main memory? No. So I'll mark it as a page fault with the star. I'll write here 2. Then the next request is 0. Whether it is there in the main memory? 7012. Yes, it is there in the main memory, so there is no page fault. Then the next request is 3. Whether it is there in the main memory? 7012. No, it is not there, so it will be a page fault. But now which particular page I will replace? So for that we'll refer the definition again. I'll replace the page which is not used in the longest duration of time in future. So I'll see the entire string here, and I'll see the next request is 3, right? So out of 0, which is just in the coming future it is used, so I'll not replace it. Then 4 is not there in the main memory, so there is no question of replacing 4. 2 also is asked. Okay, then 3 again it will be referred in future. 0 3, then 2 again. So out of it, this 2 1 0 7, I can easily see that 1 is okay, 1 is referred here. 0 is also again referred in multiple times, so even 2 also. So I can see that 7 is that particular page which will be referred in the farthest future. Okay, it is page which is not used in the longest duration of time in future. So 7 is the page which is not used in the longest duration of time. It will be referred long farther. Okay, but 2 will be referred in the near future. 1 will also be referred in the near future, at least before 7. 0 will also be referred in the near future before 7. Okay, so I'll replace 7 here. So 3, which is a page fault, then 0 1 2, this will write as it is. Then the next page request is 0. Okay, so I'll mark it. Oh no, this is not a page fault, sorry. 0 is already there in the main memory, so it is not a page fault. Let me remove this mark. So I'll just write it as it is, 2103. Then the next request is 4. Okay, now whether it is there in the main memory, no, it is not there in the main memory, so I'll mark it as a page fault. Now which page I'll replace? Again you see 2 is requested in near future, then 3 also, then 0 also, then again 3, 2, then 1, again 2, 0 also, and 1 as well. So out of all these, 3, 2 is requested in near future, I will not replace it. Then 3 also is requested in near future, I will not replace it. Then 0 is requested in near future, I will not replace it. Again 3 is requested, I will not replace. Again 2, I will not replace. Then 1 is requested. Okay, so currently in this situation, out of 2, 1, 0, 3, 1 is the one which is requested in the farthest future, okay, which is not used in the longest future. Okay, so that's why right now I'll replace 1. Why? Because 2, 3, 0, 2, 3, 0, these are requested just in the next few timestamps only, right? So that's why 1 I'll replace. So I'll replace 1 with 4, 2, 0, 3. Why? What is my goal? My goal is that why I am replacing the one which is not used in the longest future, because my goal is to minimize the number of page fault. If some page is requested nearby, then if it will be there in the main memory, then page fault will not occur. For example, now see, 2 is requested. 2, whether 2 is there in the main memory? Yes, 2 is already there in the main memory, there is no page fault. Then 3 is requested, whether 3 is there in the main memory? Yes, so no page fault. Whether 0 is there in the main memory? Yes, 2, 4, 0, 3, no page fault. Whether 3 is there? Yes, 2, 4, 0, 3. Whether this 2 is there? Yes, 2, 4, 0, 3, not. Then 1 is requested. Now we'll again see out of 2, 4, 0, 3, which one is not requested in the longest future. So 2 is requested, we will keep it. 0 is also requested, we will keep it. 1 is okay, 1 is requested, which is not there. 7 also not there. Then 0 is requested again, yes, and 1 is requested again. Okay, so now we can see that out of 2, 4, 0, 3, 4 and 3 are those two pages which is not requested in the longest future. Okay, so now I am having two options, because 4 also will not be requested, 3 also will not be requested, I can replace any one. So these two situation, this particular situation is called a tie. Okay, so whenever this kind of tie occurs, okay, where any one option I can take, I always then go to the replacement policy FIFO. Okay, in this kind of tie we replace that frame using the strategy FIFO, right? Out of 4 and 3, which one has come first? FIFO is what? First in, first out. Using FIFO, the frame which has come first, I will out it first, I will replace it first. Okay, so 4 and 3, if we see which has come first, 4 has come here, 4 has come here, but before 4, 3 has come. So out of 4 and 3, which one is the oldest one in the main memory? Okay, so that is 3. That's why I will replace 3. 2, 4, 0, 1. I will replace the page 3 here. Okay, then next request is 2, whether it is okay. This is also a paste fault, 1 was not there, right? So it is a paste fault. So then 2 is requested, it is there in the main memory, I will not replace. 0 is there in the main memory, I will not there is no paste fault. 1 is there in the main memory, there is no paste fault. Then 7, then the next requested one is 7, and now also you see which one I will replace. I will see which one will be used in the near future. 0 is used and 1 is also used. I can either replace 2 or replace 4. Okay, again for this kind of situation, this is again a tie. I have to now replace using the FIFO strategy. Out of 2 and 4, which one I will replace? The one which has come, which is there in the main memory for longest duration of time, like which out of 2 and 4, which one is the oldest one in this main memory. Okay, so if we see here, 2 has been there from long time. Yes, 2 is the oldest one, whereas 4 has came here only, first time 4 appeared here, but 2 was there for long time. And here the funda is that since it has been used multiple times, okay, though maybe in future it will not be used, so that's why here I replace to 401. It is a paste fault, I will mark it as star. Then the next request is 0, whether it is there in the main memory, yes, so there is no paste fault. 1, whether it is there in the main memory, yes, so there is no paste fault. Okay, so now I'll see what is the total number of paste fault when the number of frames are 4. 1 2 3 4 5 6 7 and 8. Okay, total number of page fault here is 8 when the number of pages number of frames are 4. Same thing I'll repeat for the second example. Okay, in the second example, again this same frame I will try to draw here, indicating the number of frames in the columns. Okay, so and the number of rows as the number of frames. Okay, so here frame number is 3, so frame number 1, frame number 2, frame number 3. This is how we will represent. Okay, 7 0, let me write the requested series sequence also. 701 203 042, then 303, then 21, 2 is there, 212, then 0 1 7 0 1. Okay, this is the requested string by CPU. So okay, let's start. So now we understood how to do 7, whether it is there in the main memory, no, it is a paste fault. 0, whether it is there in the main memory, no, it is a paste fault. 1, whether it is there in the main memory, no, it is a paste fault. 2, whether it is there in the main memory, no, it is a paste fault. Now which one I will replace out of 107? I will again see which one is used in the farthest it is not used in the longest duration of time. Out of 107, 1 is used here, okay, and 0 is requested in near future multiple times. 7 is the one which is not used in the longest duration of time, so I will replace here 7 0 1. 0, whether it is there in the main memory, yes, there is no paste fault. 3, whether it is there in the memory, no, it is a paste fault. Which one now you replace? 0 is used near future, again okay, again 0 is used, then 2 is used here, 1. So 0, since it will not be replaced, it is there multiple times in the near future. Out of 1 and 2, which one will be used? 2 is used, okay, we will not replace 2. Then 1. So here again 2 is used here, but again out of all these, 1 is the farthest one. Yes, 1 is the farthest one. After that, before I have used 1, 2 has been used. Okay, so 2 is requested sooner than 1, right? So that's why I will be replacing 1 here. So here at this point of time you may think like, but 2 is again requested here. Yes, and I am not replacing 2 also. And after that 1. So again you can see that 2 is requested sooner than 1. Okay, so that's why I will replace here 1 0 2. Okay, 1 I will replace with 3. Then 0, whether it is there in the main memory, yes, it is there. 4, whether it is there in the main memory, no, it is not there. I will be having a paste fault. And what is where 4 will be replaced? 2 here, 2 is used, so I will not replace 2. Again 3 also is requested as soon, then 0 is requested. Okay, so you see out of these 2, 3 and 0, okay, here which one is not used in the longest duration time? 3, because before 3 0, okay, before 0 3 is requested sooner, okay, and before 0 even 2 is requested sooner, right? So I will be replacing here 0, 4 3 2. Then whether 2 is there in the main memory, yes, there is no paste fault. Whether 3 is there in the main memory, yes, there is no paste fault. Whether 0 is there in the main memory, no. Okay, so again 3 4 2, which one I will be replacing? 2 is requested, 3 is requested, 4 is the one which is not requested in the future, right? So I'll be replacing here. This is 0, whether it is there, no paste fault. So 3 0 2. Then again 3 is requested, whether it is there in the main memory, yes. 2 is requested, whether it is there in the main memory, yes. 1 is requested, whether it is there in the main memory, no. Again it will be a paste fault. Which one I will be replacing? 2 is requested in the near future, 0 is also requested. So here 3 is the one which is not requested in the in the future, in the longest future, right? So that's why I'll replace here 3 with 1 1 0 2. 2, whether it is there in the main memory, yes, there is no paste fault. 0, whether it is there in the main memory, sorry, this one is 1, this is 1, it is there in the main memory, no paste fault. 1 is there in the main memory, no paste fault. And lastly 7. Okay, out of 1 0 2, 2 is the one which I am not going to use, right? So I will replace that one 1 0 7, it is a paste fault. Okay, then 0, whether it is there in the main memory, yes, no paste fault. 1, whether it is there in the main memory, yes, there is no paste fault. So how many paste faults are there? 1 2 3 4 5 6 7 8 9. Okay, so here the number of paste fault has increased. When I have reduced the number of frames, the number of paste fault has increased. Okay, so this is all about the optimal page replacement algorithm. One more example is there that you try as of your own. Okay, the strategy is same. Okay, let me end the video.